Today's lesson is lesson 15-5, and it is about exploring exploring overlap in data sets. Sorry. The mean absolute deviation, or for short, MAD, is a measure of variability that describes how far the data values are spread out from the mean of a data set. We talked about this word or phrase, measure of variability. A measure of variability measures how varied or spread out your data is. We've talked about how range and even interquartile range are measures of variability. The mean absolute deviation is another measure of variability. So we'll go through the steps of how you can calculate the mean absolute deviation. First off, you have to find the mean. So in this example, the mean is 10. They've already calculated it for us. But we would add up 7 plus 8 plus 8 plus 9 plus 10 plus 11 plus 11 plus 13 plus 13 and divide by, let's see, 9, because there are 9 data values. But we get a mean of 10. Next, we find the deviations. The word deviation comes from the word deviate, and it has to do with how far or how far away is basically what it means. So when we find the deviations, we're looking at how far away each data value is. So you can see we've taken our data points and we're going to think about how far they are from the mean. So we say that 7 is -3 away from the mean of 10. Negative because it's below the mean of 10. 8 is -2 away from the mean of 10. 9 is -1 away from the mean of 10. And if you go greater than the mean of 10, you might be 3 away from the mean or 1 away from the mean. The data point that's exactly the same as the mean is 0 away from the mean. So we're changing our data points into numbers for how far away they are from the mean. Then we want to find the absolute deviations. If you remember us talking about absolute value earlier this school year, like if I said, and we use bars, if I said what's the absolute value of -4, we would say it's just +4 because it's 4 away from 0. When we find the absolute deviations, basically we just want to know how far away they are. We don't care if it's above the mean or below the mean. We don't care if it's positive or it's negative. We just want to know just how far away it is. So we only think about positive values. So we have all our deviations and we're just going to think of them as positive values. So even though 7 is 3 below the mean and 13 is 3 above the mean, they're both 3 away from the mean of 10. And then we find the mean absolute deviation. So we find the mean of all of the deviations. They show the work here, but let me kind of go back to the last picture so I can be more clear about what they're doing. So here's all of our deviations. We want to find the mean of them. So we add them all up. And then we divide by how many there are, and there are 9. So they do that work here. They add them all up and divide by 9. When you add them all up, you get 16, and you divide by 9, you get about 1.8. So we say that the mean absolute deviation is 1.8. What does that mean? If the mean absolute deviation is 1.8, this means that on average, the data values are about 1.8 away from the mean of 10. So even though 7 is 3 away from the mean of 10, and 13 is 3 away, and 11 is 1 away, and 8 is 2 away, and the one here on 10 is 0 away from the mean, we are given an average, a mean about how far away all the points are from the mean of the data. All right, let's try some examples. Okay, so we're supposed to calculate the mean absolute deviation for the heights of second graders. It tells us that the mean is 50. So I'm going to go ahead and mark that. It helps me to be more visual about what's going on. And it says to round our answer to the nearest whole number. Okay, so first off, if we go back to our steps, we have to know what the mean is. And we already know the mean. So now we start looking at how far away are all the data values from this mean. Now, if we go to our first point here, it's at 43. We would say that's 7 away from the mean. It's like -7 away from the mean because it's behind the mean. But we don't really care about positives and negatives because we're just going to do the absolute deviation. So we can say this point is 7 away from the mean. If we looked at a point up here, this one is at 57, so it's 7 away from the mean as well, a +7. But like I said, we're just going to do the absolute deviations. So we're just going to look at how far away it is. We're not going to worry if it's positive or negative, if it's in front of the mean or behind the mean. All right, let's keep going. So this value point is at 47, so it'd be 3 away from the mean of 50. And I'm just going to write the numbers just right on the graph so I can keep track of all my values. If that gets confusing or too crowded to write everything, you can write the numbers off to the side too. All right, 48 is 2 away from the mean. So we have three data values that are 2 away from the mean. These data values are 1 away from the mean because they're at 49. These data values are 0 away from the mean because they're right on the mean. These are also 1 away from the mean. These are 2 away from the mean. These are at 53, that's 3 away from the mean. And this one is 4 away from the mean. Okay, so we have all of what we call our deviations. Now we want to find the mean deviation. So we want to average all those numbers that we just wrote out. So we need to add 7 plus 3 plus 2 plus 2 plus 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 0 plus 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 3 plus 3 plus 4 plus 7. That's a ton of data values. Okay, so this is how far each one of them are from the mean. So we got to add them all up. And you got to really be careful about not making any mistakes in your calculation. You don't want to type the wrong thing. So I'm trying to keep my eye on what's being typed in so I make sure I'm not messing anything up. Okay, so I got 48 for the total, And then we're getting the average, we're getting the mean, so we would divide by how many data values we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Oops. So we do 48 divided by 25, 1.92. It did say to round to the nearest whole number, so we can just say that the mean absolute deviation is about 2. And what does that mean? That means that on average, our data is about 2 away from the mean. So in a sense, you could say like most of our data is somewhere between 48 and 52 because that would be 2 less and 2 more than our mean. And that's where most of our data is. So that makes sense. Okay, this is asking you to calculate the mean absolute deviation for the heights of 7th graders. It tells you that the mean is about 61 inches round to the nearest whole number. This is an excellent time for you to pause the video and try the question out to make sure you can do it on your own. Okay, so what you should do is begin by thinking about where the mean is. So it's at 61 inches. And think about all the deviations. Like 55 is 6 away from 61. 64 is 3 away from 61. We're marking all the deviations. Any values that are at 61 have a deviation of 0 because they're right where it's right on the mean. It's not any distance away from the mean. But then we don't really care about positives and negatives, so we would just look at the positive version of our deviation, just how far away it is, whether it's in front of it or behind it. We need to add up all of the deviations and divide by 25 because there were 25 values, and we get a mean absolute deviation of exactly 2 inches. The graph shows the height distribution of samples of 2nd and 7th graders. Explain why the MADs of both samples are the same. In our examples, we found out that the MAD was about 2 inches for 2nd graders, and it was 2 inches for 7th graders. So, 2 inches for the 7th graders. So what's that mean? Does that mean that the heights are the same for the 2nd graders and the 7th graders? Obviously not. That wouldn't make any sense. 7th graders are a lot taller than 2nd graders. And when you look at the values here along the number line, a lot of our 2nd graders are somewhere between like 47 and 54 inches. Our 7th graders are more around 58 up to 64 inches. Our 7th graders are definitely taller. So then what's it mean that their mean absolute deviations are the same? Remember, the mean absolute deviation describes how far the values are from the mean. So we could say that the heights of 2nd and 7th graders are spread out in similar ways. So it's not about how tall they are is the same because the MAD is the same. It's about how it's spread out. Even if you look at the picture, it's all kind of grouped together in a similar way as the 7th graders, even though they're taller. So it's important that the mean absolute deviation is interpreted as how spread out the data is. All right, go ahead and move on to part 2 of this video.